This is Euclid Book 1, Proposition number 2. And the first thing I'm going to say is I want to apologize to everybody. The main reason is that in Euclid Book 1, Proposition number 1, I heard a lot of complaints. They couldn't see the picture. So what we're going to do is I'm going to use my smartphone to take pictures of this, and I'll turn that into a YouTube short so you can actually see the pictures if you can't see very well with this. Otherwise, I could insert the pictures into this actual video. We'll see how that goes. I know that the paper here is not exactly the greatest of shape. I bought this several years ago. I had to suddenly move, and when I did, the paper got wet because of the snow and ice, and there you go. So I'm going to try to do this the best I can. I do have a brand new compass that'll help us out. Hopefully you'll be able to see the stuff better. And I got a ruler, and I got an ink pen. And the reason for the size of the paper is because of the proof itself. We're going to draw a lot of circles, and some of them will be a lot bigger than you can imagine. Okay? So anyway, we're going to go through this. This is Euclid Book 1, Proposition number 2. It says to place at a given point as an extremity a straight line equal to a given straight line. We're going to have A be the given point. Okay, we're going to put A, say, right there. I'm going to call this A. Now, they say to give BC a given line. Okay, we're going to do that in a minute, but first of all, what we want to do is give ourselves point B. Okay, and there is a good reason for this, and I'll explain that in a little bit. So, all right, got a Charlie horse on my leg. Wish I could ride the Charlie horse. Maybe I could go to town. Who knows? Anyway. Now then, we're going to draw a 1/8 line between A and B, okay? And there is a reason for this. Okay? And we're going to call this point B. Now, with center A and distance AB, we're going to draw a circle. Okay. Now then, we're going to draw a line from point B. I'm going to draw it about 1.5 inches. And it's going to be called BC. Now then, let's go on here, shall we? Now I may have to pause this. This is a high-def video, so I may have to pause this from time to time. Okay. Let's read this proof again. It says, let A be the given point and BC be the given straight line. There's the given point, there's the given straight line. Thus it is required to place at the point A as an extremity a straight line equal to the given straight line BC. So we're going to draw a line from A that's going to be equal in size to BC. Okay. The proof goes on to say as follows. From the point A to the point B, let the straight line AB be joined. Okay, we're going to do that. That was a little sloppy. Now then, the next instruction says as follows. Alright. And on this line AB, let the equilateral triangle DAB be constructed. Okay, so what we're going to do, we've already got this circle right here. We're going to make an identical circle with center B and outermost edge A, like thus. You have it. Make sure you're seeing all this. Yep, so far so good. Sometimes these Euclid proofs go a little longer than I anticipate. Alright, now. So, we now need to form equilateral triangle DAB. Okay? Well, we're gonna form it all right. And point D will be right here. Okay? First thing I'm gonna do is I'm gonna put this like this. This like this. You have to go back just a pinch. Still have to move back just a pinch. And we'll move it back into view in just a second. Okay. And you're able to see that. Very good. So we have constructed equilateral triangle DAB. Okay, we're back. Let the straight lines AE and BF be produced in a straight line with DA and DB. Okay. What we're going to do is we're just going to extend DA out a little bit. Okay? Just a little bit further out. Son of a buck. Okay. We're going to put point E right about here. I believe that's the correct one. Is E. Yep. E. Okay. Now then, we're going to extend this out to another point E, and F. Okay? Alright, let's go take a look, see if you can see all this. So far, so good. Great. Okay. Now, the next instruction says, with center B and distance BC, let the circle CGH be described. Okay. In a moment, you're going to see why I had to use this paper. Okay? Now, where's point G? There is point G. Okay? Where's point H? Point H could be literally anywhere. How about there? There's point H. Now then, the next instruction. And it says, and again with center D and distance DG, let circle GKL be described. Okay? So, now you say, okay, there's the circle. We got a point K up here, and we got a point L right there. And we need to take a picture. Okay. Let me make sure you're still able to see all this. You are still okay. Very good. Now then. Now, since point B is the center of circle CGH, okay, well this is CGH right here, and point B is the center of it, then BC is equal to BG. Well, BC, this line right here, and we'll put a number 1 here, is equal to BG. Okay? It also says, again, since point D is the center of circle GKL, well, where's GKL? This is GKL right here. That's that circle right there. And since point D is the center of it, no, that's point D. Point D is the center of this. Then we can say DL is equal to DG. Well, what's DL? That's this line right here, and we're going to put this number 2 here, and it's also equal to this line right here. So that's DG right there. Okay. And in these, DA is equal to DB. Well, this is DA right here, so we've got number 3 there. And this is DB right here, so we've got number 3 there. So, let me make sure I got enough time left. Yes, I do. Okay. So the remainder AL is equal to the remainder BG. Well, where's AL? Well, here's AL, and we're going to put a number 4 right there, and it is equal to BG. This is line BG, so we're going to put a number 4 here as well. So we got 2 here, 4 here, 2 here, 4 here. Okay. But BC was also proved to be the equal of BG. Okay, so what it's saying is that the length of BC is the same length as line BG. So this length here, BC, is exactly identical to this length right down here. Perfect. Therefore, each of the straight lines, AL and BC, okay, so we have AL here, BC up here, they are both equal to BG. So this length here is equal to this length here. Okay. And things which are equal to the same thing are also equal to one another. Therefore, AL is equal to BC. The length of this line here is equal to this length here. Therefore, at the given point A and the straight line AL is placed equal to the given straight line BC, being what it was required to do. And that is Euclid Book 1, proposition number 2. I hope you enjoyed this presentation. The next time I have a presentation, I'm going to use a much smaller piece of graph paper, and you'll be able to see it for yourself. Alright? This is Ted the Speed Learner signing off for tonight. I will tell you more in a future video, so I'd like for you to stay tuned.